Hi everybody, today we're going to talk about forward contracts. Let me write it down. Forward contract. So what is a forward contract? It is an agreement you make. So here you are at t equals 0. You enter into the forward contract. So you enter into here. And then at some time in the future, t equals big T, you have to buy an asset at price F. Buy asset at price F. Now you might be wondering, what is the cost of entering into such a contract? We're going to set it up in such a way that it doesn't cost you anything to enter it because you haven't done anything in the beginning. But then later, the price of the underlying asset, which we call S of t, where t is the same variable as time, it might go up or it might go down. St might be greater than f, or it might be less than f, and depending on that, the value of the contract, it increases or decreases, right? So then, so the value of this contract then at time t equals big T is equal to S t minus f, right? Because the moment you come to this time spot at t equals t, you immediately buy the asset um, at price F, and then you can immediately sell it on the market for ST, gaining a profit or a loss of ST minus F, depending on if ST is bigger than F or less than F. So now the question is, what should be a fair price for F? If we assume that it doesn't cost anything to enter into this forward contract. For example, if we had to pay $100 to enter into the forward contract, then we might take F to be a smaller value because it costs something for us to enter into this contract. Therefore, we expect the cash flow in the future probably to have positive value as well. But if we assume that it costs nothing to enter into the forward contract, it's free in the beginning, and then later we are obligated to go into this scheme where we buy the asset and sell it. What is the fair price for F? So in order to understand that, let's construct a portfolio. So here is our portfolio. We're going to buy this forward contract. Sorry, I should say this is time equals 0. We're going to buy the forward contract. And then at the same time, we're going to short S at t equals 0. So what does short means? It means we are going to borrow the stock from somebody and immediately sell it. And this means that at t equals 0, again, this is 0 because it doesn't cost anything to enter into this forward contract. And we're going to short it, which means we're immediately going to get a cash flow of plus S0. Okay. And at the same time, what we're going to do immediately with this cash flow is we're going to lend it. So we're going to get minus S0. Now at time equal t, we get our cash that we lent out, and its value now, because of interest, is bigger than what we originally lent out as 0. Now we get a S0 plus a little bit back. So divided by the discount factor. I realize I haven't talked about what a discount factor is yet. I can go into that soon. Basically, you can think of it just as 1 over the interest rate to the power of t. So this is compounded. If it's t years, then 1. It's basically just a more general way of saying with interest. Okay. So now we shorted S at t equals 0. So now we have to repurchase the stock, and we're repurchasing it at ST. And now the value of this contract, let's just say we immediately sell it, we already derived what the value of this contract is ST minus F. Okay, so basically ST is a totally random variable. We have no idea what the value is, but if we add up all the cash flows that we've generated by constructing this portfolio, we get that the cash flows at time t is equal to, these cancel out, and we just end up with S0 over d of 0t minus f. Okay, so now looking at this, it cost us 0 to enter into this portfolio. Therefore, our cash flow should also be 0, or it should be 0 times or 0 divided by the discount factor, which is 0 divided by something non-zero is still 0. Therefore, if we move the f to the other side, we get that f is equal to S0 divided by D0t, which is the discount factor. So therefore, we found a way to price our forward contract, or we found what the correct price is, given that it costs 0 to enter into our forward contract. So it costs us 0 to enter this forward contract, and the price F that we have to pay at the end for this forward contract should be the initial price divided by the discount factor. So the discount factor is less, it's less than 1. So this F is actually bigger than S0 if the interest rates are positive. So what does this mean? This means that you actually have to pay, like let's just say the current price of the underlying stock is 100. Then that means that the price you will have to pay after at t equals t will be actually greater than 100. Why? So the person who you're making a deal with to do the forward contract is actually they have to sort of carry the stock in some sense. They have to hold it, right? They have to have the money sort of available to for you to buy the stock from, right? And so we've constructed this portfolio in this way, which kind of helps to elucidate why we need to do this whole, like we basically need to have this sort of money available to sell a stock, right? Like somebody has to hold the bag in some sense. Okay, so I guess I didn't mention what discount factor is. So discount factor, so there was a part on spot rate. So we've been using interest rate R for now, but actually instead we're going to use something called a spot rate of T. So as it turns out, it's when you lend, let's just say for 1 year, your interest rate is lower than if you lend for a longer time. So tying up money for a long time is seen as less advantageous. Therefore, it has a higher interest rate, like a higher return, if you keep your money tied up for a long time. So S2, for example, is most often greater than S1. And then S3 is greater, where S3 is the length of how many years you're tying up this money. So that from now on, instead of using R, which is independent of the length, we're going to, let's just say you want to calculate the interest rate for 3 years. Instead, it's going to be 1 plus 1 over S3 to the power of 3. And then if you tie up for 2 years, then it's 1 plus S2. And these S3 and S2 are different. Okay, so then a discount factor is defined as just from 0 to t is defined as 1 over 1 plus st to the power of t, which is this thing here. So this means what is the cost of, and this is less than 1. So it's basically how much more money is worth right now than in the future, given that we're tying up our money from 0 to t. Okay. So there's another concept that we go over, which is the I think it's called the forward rate. Let me just check just to make sure. Yeah, the forward rate. So the forward rate, F of UV, is the interest rate quoted right now. So this is quoted at time t for a future rate. So this is between U and V. So these are U and V are both time periods. So here we are at time equals 0, and then we have U in the future and we have V. And the FT of UV is the interest rate quoted between these two. So we're going to borrow at U, and we're going to give it back at V. So there's a way you can compute this in terms of spot rates. So imagine the following sort of situation. So you're at t equals 0. Immediately what you're going to do is you're going to lend up until V. So this will be S of let's just say u plus v, right? This is the interest rate that you lend it at, or sorry, u s of v. Sorry, not u plus v, s of v. And at the same time, you're going to lend at s of u, and then immediately afterwards, you're going to lend that same money, I guess compounded, right? At this is the forward rate, right? ft uv, because this is exactly what the forward rate is. It's the price for lending in the future. So now you can see we've gone sort of the same direction. We've lent money twice here and here once, and hopefully these should be the same thing. So it should be true that SU, I mean, realistically, this is SU to the power of however many years, I guess. I mean, the forward rate are defined as percentages, so 1 over SU to the power of U, and then 1 plus F of UV to the power of V minus U should be equal to 1 plus S V to the power of V, right? And then through some algebraic manipulation, you can determine what the value of F is. Okay. I guess there's also some examples about forward contracts, but for me, what's interesting to understand is what is the, so as you can tell here, we have the value of a forward contract, right, which is equal to ST, the price at this, right? So now this F, right, is equal to, as we know, it's S0 divided by D0T, right? Right. Okay. I don't have time to talk about this, but hopefully that has given you a good understanding of what a forward contract is. I'll see you in the next lecture. Thank you.